Just let me know when I should start. Okay, so I think we are live. So yeah. Okay. All right. Hello, everyone. My name is Harshit Tyagi, and I welcome you all to this session on cricket score prediction. And as you guys already know, an IPL season that's been happening, and there's just talks around all about IPL. And in this particular analysis, in this particular prediction and session, what we're going to do is we're going to simply talk about how we can go about analyzing the past data that we already have about the previous matches that has happened, and also how we can merge data sets, how we can explore them, and how we can leverage machine learning algorithms to predict different sort of variables. There's sports analytics is a very vast field, and there you get a lot of statistics, and you can do a bunch of things with them. So without any further ado, let me just first introduce you to two TAs that we have. So there'll be two TAs who would be helping you out with your questions in the chat. So in order to make it a success for all of us, keep posting your questions in the chat. And if there is anything ambiguous or you do not understand anything, feel free to chip in and write in your queries in the chat, and we'll try and answer all of your queries. So let me quickly share my screen. And so here's the IPL match analysis and winner score prediction that we are going to do today. So these are the topics that we'll be covering. Again, I will show you where to get the data and all of those things. You'll have the repository and everything like after the session ends, or if you want to clone it, I'll provide the link as well. So these are the topics that we are going to cover. So first of all, we're going to look into, once we have the data, so we have taken the data from Kaggle or about for like last 10 years, 2008 to 2019. And all of the matches that have been played so far. And so the concepts that we are going to cover today in this particular session are going to be exploratory data analysis. So we're going to look into how to peak, first of all, initial exploration of the data set, how to clean data set, how to manipulate the data set, and find out missing values and a bunch of other things in the cleaning process. Then we're going to look into how do we define the problem statement, because there are so many variables, so you can get lost at any point of time. Now, one thing that you should always make sure is that you have a clear understanding of what you want to get from the data. Then the third point is visualizing important features. So we'll see how we can visualize a few things like toss winnings and match winnings. And second segment would cover the data preparation process. So we have label encoding and one-hot encoding of all the categorical variables. So I'll be covering label encoding and give you an intuition of how one-hot encoding would actually transform the data, and then you can run it over as a home task. Then we'll look into modeling. So there we'll see how we can split data, how can we choose, like what all algorithms we can choose for this classification problem that we would come up with. And the third is cross validation. So we'll see what are the best ways to actually evaluate our model that we have, and what are the best practices regarding splitting the data into training and testing, and why we should not touch the testing set, up until once we are, up until we are really sure, as in, yep, we are satisfied with the performance of the model, and we are ready to go into production. Then the last part that we will be covering is checking the model on the test data. And there are a few other things that I have gathered so that you can actually build over it to add more complex variables, more complex data set, and build over it to analyze and predict many other variables. So so here I am. So I have already done the analysis. So this is all available on GitHub. And now this is going to be more of a hands-on session. So we won't be like diving into the mathematics or anything of that sort in the about the models. But yes, we would be doing that all hands-on. So yeah, let me create a new notebook. So all those of you, I'm using the Jupyter Notebook first of all here. This is the directory page basically, and you can actually create. So if you want to create a new notebook, so you click on new and then you click on Python 3. This takes a few seconds and then it creates a new notebook for you. So here you can actually do everything that you want to do with your analysis and everything. Like you can document your code, you can actually write the code as well. So let's quickly change the title. So you can change the title. Let's say Apple. Okay. So let me give you a brief intro to this interface, Jupyter Notebook interface. So we have like a couple of different types of cells. So this is a code cell, as you can see from this drop down over here. And so we have code, we have Markdown and raw NB convert and heading. So heading and Markdown is just about the same. So most of the times we would simply be using code and Markdown. And let's say this is the code. So you can type in like any code in Python. So this is a Python notebook. So you can run it and it'll basically run the code for you. Then another type of cell is Markdown, which you can use to actually document, or if you want to write any sort of steps or with the segment heading or whatever that you are doing. So let's say this is IPL prediction notebook. I can move this cell up and down using these arrows over here. So this heading should always go on the top. So here I have put the heading on the top. Now, how can you run this cell? How did it go from here to here? So you can actually click on run over here, or you can click, or you can just hit Shift plus Enter on your keyboard. So that will run the cell for you. And if you want to add a new cell, so here you can click on plus. If you want to cut a cell, you can click on this scissor icon and it'll delete the cell. In case you want the cell back, so escape plus Z is the shortcut and it'll get your cell back by chance if you delete any particular cell. All right, so this is enough for us to get started. So let's dive right into it. So the first step is to import Python libraries. I am assuming that you guys have some experience or some knowledge, some familiarity with the Python libraries. So the data science libraries, mainly Pandas, Numpy, and Scikit-learn is what we'll be using majorly over here in this particular session. Then, and for visualization, we'd be using Matplotlib and Seaborn. So firstly, let's import the libraries. So the main data analysis and data manipulation package is a very important package called Pandas. So we import Pandas as PD. Then the second most important package is Numpy to handle to handle multiple multi-dimensional arrays. It's a core scientific computation package, Numpy, and Pandas gives you a special data structure which is called a data frame, which you can use to manipulate all your features, targets, rows, everything. So we'll see how it does that. I have done import Pandas as PD just to abbreviate Pandas so that I don't have to like write Pandas every time I go into it, every time I use it. So import the libraries, and another important library that we're going to use is Matplotlib. And inside Matplotlib, we would be mainly using the pyplot module, and we'll import it as PLT. These are mainly the conventions that we have about these imports, as in like Pandas is usually imported as PD and Numpy is usually imported as NP. And then we don't want to look at any warnings, so you can also switch them off using warnings dot filter warning. Okay. Yeah, you can hit tab and it auto complete, but sometimes it's a little slow, just like in this particular case. So again, I've written my code. I've written all the libraries that I would need to be used in this particular notebook. So you can hit either this run button or you can hit shift plus enter on your keyboard. So as you can see, Esther, this shows you that the notebook is still running. And once it's done, so if there is an error, it'll show you an error. So yeah, we have successfully imported all our libraries. Now the next step is to load the dataset. So the dataset is this dataset from Kaggle. We have two files over here, matches.csv, which is match by match data, and we have deliveries.csv, which is like ball by ball data. We would be mainly using matches.csv in the first segment, and then I'll show you how we can incorporate the other file, which is the deliveries.csv. So here we'll be loading the data, and I have the data downloaded already. So it's here in my data directory, and I have got matches.csv and deliveries.csv already with me. So what all I need to do is use the CSV read CSV function. So Pandas provides us the method. So let's quickly load the data, load these files into a data frame, match underscore df, and then go PD. So in the Pandas library, I have this read underscore CSV function. It takes the path to the file data slash matches.csv. And once you have provided the path, it will read the file. It will return a data frame, which is now stored in this variable called match underscore df. And let's say we run this, and if we want to see like what's inside of our data set, we can actually do this. So match, so the last line is basically what this cell output would show you. You can actually also do print in case you want to print something in between, but the last, if you are putting something in at the last, then it will basically show you what that variable contains. Okay, so the match underscore df, so our file is correctly read, and it has got a few variables. You can see ID, season, city, date, team one, team two, toss winner, and a bunch of other variables that we have. Now, this is a long data set. So you have 756 rows and 18 columns, as can be seen. If you want to look at like quickly, like say the first few rows, you can do match.head. It only gives you the first 5 rows. You can also change the number of rows that you want to look into. So let's say if you want to see 10 rows, you can provide 10, and it'll print, it'll show you the first 10 rows. And if let's say you don't want to look at the first 5 or the first 10, you can actually also use sample, which will give you a random sample of rows. So match underscore df dot sample. Let's say I want 10 samples. So these, as you can see, these are like random samples pegged up from our data frame. Now, the next thing is to read the other file, which is our deliveries file. So let's read that file as well. Let's store it in delivery_df. And again, same procedure, pd dot read_csv. Pass the path to the file, data slash deliveries.csv. Look into deliveries_df dot, let's say, what does the data contain? I'm interested in looking at the first 5 rows. So by default, it shows you 5. So we have quite a few variables here. This is 21 columns, and I'm only printing the 5 rows. So that's why you are looking at 5 over here. So this is like ball by ball data that we have: match ID, inning, batting team, bowling team, over, ball, batsman, non-striker, bowler, and a bunch of other variables that we have over here in the deliveries .csv. All right. Now, the next thing that we can use is this is about peeking at the data set. Now we can also look at the information of what this data set contains. So let me put this. Okay, match_df dot info. So this is another attribute function, that method function that this data frame object has, which we can use. So match_df dot info, call the invoke the info method, and it gives you all the information about the number of rows. First of all, 756 entries in the match data frame, and these are the columns from 0 to 17. That is 18 columns: ID, season, city, along with the non-null values. So here you can actually get a hint of if the data set actually contains like missing values or not. So if you have 756 entries, like like ideally every column should have 756 entries. So here we can see city column contains 749, and then winner column contains 752, umpire 1 754. So there are some missing values in this data set that we might have to address. All right, so that was about the how you can learn about the information. Similarly, you can run it for deliveries data frame dot info. So this is the information about our delivery data set. We have match ID, batting team, bowling team, over, ball, batsman, non-striker. So you can see that there are so many variables that we can actually use, and the analysis also can go in any which way. So it depends, like do you want to like predict the score? Do you want to predict who is going to win? Do you want to predict who is going to, so if let's say if a particular thing happens, let's say if a team wins a toss, what are the chances that they'll win the match as well? So you can look into various directions, and that's why sports analytics in itself is a huge field. So that's how you can look into the information of the data set. Now, the next thing that we're going to do is exploratory data analysis. So let's quickly add a heading. Exploratory data analysis. So here we're going to look into a bunch of things. So first we'll try to look at all the teams in the teams and the winner column. So here let's quickly check match_df. So we have team 1, team 2. You can see we have team 1, team 2 in that particular match. Then we have toss winner, toss decision, was DL applied or not, who was the winner, win by runs, win by wickets, and a bunch of other things. So match_df. So if you want to access, or if you want to look into any of the variable, any of the column, sorry, so here you can do like this, square brackets, just as you do it in an array or list. So I am interested in looking at the winner, so who all won how many matches. So let's first like look at like what all unique variables or what all unique observations do we have in this column. So match underscore df winner, and then I invoke value underscore counts method. So this gives me a count of all the observations that are present and their frequency. So basically the count. So Mumbai Indians appeared 109 times in this winner column. So that's what it's showing me. So Mumbai Indians is 109. Mumbai Indians has basically won 109 matches. Chennai Super Kings 100, so on and so forth, up until Rising Super Giants. And you have to keep a keen eye, like keep your eyes open while analyzing these data sets, because there can be something suspicious or something that's wrong, or a typo, anything that needs your attention. So you have to keep your eye open while looking into what these functions or methods show you. Then let's look at match underscore df, like what all teams played. So okay, same way, we have a team 1 column. So we want to look into like the count or the frequency of all the teams that played. So not value count, okay, it's value counts. Yeah, so you can see match underscore df team 1 dot value counts gives you Mumbai Indians has appeared 101, so that is team 1. So the other matches that they would have played would have been like would it be in team 2. And similarly Kings 11 91 times, Chennai Super Kings 89 times, so on and so forth. Now one thing that you should look at over here is we have Rising Super Giants, which has like appeared as team 1 8 times, and there is another team called Rising Super Giants. So the team name is same, it's just this small s that is present over here that can cause errors in our code. So we have to keep this in mind, that we have to address this. So it's actually the same team that we are looking at here. So the next thing that we do is let's look at a few missing values. Do we have any missing values? So checking for missing values. So we have an is null method. So in any variable that you want to check, you can actually do. So let's say we saw in the information that we printed about match underscore df, we saw that we have city column has 749, and then winner column. The winner column is the most important column. So for our in a particular analysis, we would be interested in looking at who will win the match. So here we are going to we are going to use the winner column as a target variable. So that must be in good shape. So it has got missing values. So let's quickly see what that is all about. So first, what we're going to do is we are going to check match underscore df, and I'm going to check the winner column. Now, in the winner column, I want to check all the rows that has null values. So is null method, and that is how. So basically, in the match underscore data frame, I want to look at all the rows where the winner column is not null. So is null should be, it basically gives you true and false. It sets true and false. So whenever it encounters an NaN, it basically marks is null as true over there. So I want all the rows where we have a null value. So if we look at this, it's kind of like a filtering method that I have applied over here. So this is my data frame, match underscore data frame, and I want to print all the rows in this data frame, and inside of it, I want to print, like I provided a filter query. So here I am only interested in looking at rows which have null values. So we've got 4 over here, and you can see we have result as no result, and winner is mentioned as NaN. So basically there could have been any reason, rain, or the match didn't happen, or what, for whatever reasons. So we need to address this, and match underscore df. So we can actually drop these rows, or you can like replace these NaNs with some other value that you seem is fine. So one, I can show you like how you can replace it. There are very less like low chances of a draw, but let's see if we can do that. We can actually you can actually drop these rows as well, and that would be okay for this particular analysis. There are different ways to impute missing values. That's beyond the scope of this particular session, but yeah, whenever you have a data set which contains a lot of missing values, so you have to decide based on your problem statement, the context of the business, and different other factors, that do you want to impute those missing values, do you want to delete them, and if you want to impute or fill those missing values, how would you fill those values, what strategy would you use? So that is another conversation. So match underscore df, so what we are going to do here is the null values, we're going to replace them with, let's say, draw. So match underscore df winner, and I'm going to fill all the NA values. So you can fill the NA values and pass like what do you want to fill it with. So let's say draw. I want to fill draw instead of these NaNs, and in place equals true, so that everything happens in the rows itself, everything remains intact. And run this cell, shift plus enter. And if you want to now check, if you run this now, if you run this statement now in this new cell, you can actually see that now we do not have any null values. So the winner column is basically all filled with, so you can actually check it in the info as well, or you can do the value counts as well. So you can see the winner column now contains 756 null values. So that part is addressed. Now, one thing, if we see in this data, we have team 1, team 2, toss winner. So all of these are textual information. All of this is textual information. We have strings of team names over here. And machine learning in general, or computers in general, understand numbers rather than text. So what we'll have to do is we'll have to come up with a scheme where we can actually encode these names, these titles of these teams, into with a number. So we can use different methods. So let's quickly create a dictionary which we can use. So team underscore encodings, and this dictionary, what will it contain? It will simply have the key. Let's say the first team is Mumbai Indians, and I pass a key value. So this is my key dictionary. This is my key of my dictionary, the first key, and my value that I've assigned to Mumbai Indians is 1. So wherever, so basically I'm going to use this entire dictionary. We'll do it for all the other teams, and we're going to use this dictionary to replace all the names with these encodings that we have defined for all of the teams. So this is my team encodings. I have done this for all the teams. So let me quickly copy paste that. Command V. Okay. So this is my team encodings. I have encoded all the teams. And now if you see over here, I have addressed the rising supergiants issue, which we encountered earlier while looking at the matches information. So here you see the team 1 column that we looked at, the value counts. We had rising supergiant and rising supergiants as well. So there was a typo. All I've done is I have addressed the same same encoding to both of these. So that will basically address, so if we'll group them or aggregate them, that'll give us the same value. So team encodings, we have provided the same value, rising supergiants. So we have encoded them same. And now what we need to do here next is, this is the general encoding dictionary. Now we need to create specific to each column so that we can apply it directly. So for each column, we'll have to apply this dictionary to, so let's say team encode underscore dict, and then we do it for all the columns that we have. So team1, team encodings, then we do it for team2, team encodings, and then we do it for toss winner, team underscore encodings, and then there is another variable which contains team names, team1, team2, toss winner, and then this winner column. Winner column also contains the name of the team, so we'll encode that as well. So our dictionary is now ready. Now we need to apply these rules to our data frame. So match underscore data frame is the main data frame that we are using. Here we use the replace method. So we have a replace method to which we'll pass this team encode dict, team encode dict, and again we need everything done in place. And then if we look at the data frame now, so let's look at how this data has been transformed now. So you see team1, team2, we have 10 and 3, and toss winner is 3. Again, winner is 10. So let's look at, let's try to compare if we have done it correctly or not. So we have 10 and 3 in the first match. So 10 is Sunriser Hyderabad, and 3 is team2, that is Royal Challengers Bangalore. So the first match was Royal Challenger Bangalore and Sunriser Hyderabad. And if we look at over here, and let's just print that over here itself. Okay, we have already changed. So yeah, so okay, yeah, so team1, okay, this is a sample. We can actually look at over here. Okay, let's quickly run it and do it again. So the first match you see was between Sunriser Hyderabad and Royal Challengers Bangalore. So now we'll have to run all of these again. So now the team encoding part is done. Now what we need to do next is we're going to explore the city column, the other column that has missing values. So let's do that as well quickly. So what we are doing here is we are trying to first address all the missing values, and based on that we'll come up with our problem statement where we'll choose a particular set of features, particular set of variables, and then decide like what we want to predict based on what all features. So missing values in city column, so match underscore df, and here city. Again, you can first, let's look at the value counts for the city column. Run this and we will see. Okay, it's taking a few seconds. And by the time it returns, let's also write the next query, which is where we want to look at all the null rows, all the missing values rows. So it has got us the result. So we have Mumbai, Kolkata, so many others. And yeah, so these are the cities where these many number of games have been played, basically. So now let's look at, so we saw in the city column, there was like 749. So we should be having like 7 missing values. So let's check what's that is all about. In the city column, I want to check all the null rows. So is null should be marked as true for those rows where I have missing values. So let's run this. And we have these many rows. So you see the city column, we have all NANs over here. Team 1, team 2 is fine. Then if we can find something else. So you see the venue over here. We have the venue, but we do not have the city. So that can be easily addressed. So venue is Dubai International Cricket Stadium for all the teams. So yeah, so all of these cities, all of these rows where we have a missing city, all of these were played at Dubai. So we know how we can address this. So match_df, we are going to replace it with Dubai. So again, match_df in the city column dot fill NA, and then pass Dubai to that city in place equals true. So now we have addressed that as well. You can check match_df.info, and here we have. So if you look at the information, basically the data type actually gives you which all were strings, which all needs to be addressed by some sort of encoding, or do you want to drop them, or whatever that you want to do. Team 1, team 2 now have been converted into integer data type, and toss winner as well, the ones that we have added the encodings for. And the city column, if we see, it now contains 756 non-null values. So all of those values, missing values, have been imputed correctly. Now the next step is to drop all the rows, but before that, let's quickly look at one very important method as well, which is to look at the summary statistics of the data frame. So that is how you can understand like what's the average of that particular column, standard deviation, and a bunch of other statistics that we would be interested in looking at. So here the describe method basically gives you this count, mean, standard deviation, minimum value, 25th percentile value, 50th percentile, max value. So for all of these columns, you can actually see that count. We have 756 in almost all of these. So that is great. So all of these are numerical columns. The string or the object-based data type columns have been dropped from this summary statistics, but you can actually provide or calculate the statistics for them as well. For there, you'll find frequency and a bunch of other factors or statistics that you might find interesting. So we have got average for each of these. Average might not make sense over here. Win by runs, here 13, winner, okay, that's encoding, so that's not required. So but this is a very important method where you have a lot of numerical variables. You can actually use describe method to get a lot of insight into what the data set actually contains and what all can you look into. Then let's look at, so what we have here is we can actually look at like team 1, team 2. We can use the venue column, we can use the city column, and we can look at the winner or the toss winner column. So let's see like what effect does toss winning has on match winning. So toss wins and match wins by each team. So let's convert it into a markdown itself. Run this. Now let's code the next part. So we want to find out all the toss wins. So here, if you want to find out which all teams won the toss, so it's very simple. All you have to do is match underscore df, use the toss win column, toss winner, and dot value counts again. And this basically, let's say we want the sort equals true, we want the sorted results. And let's also look at, so these are the toss wins for each of the team, 1 to 5. So 1 is basically Mumbai Indians, as we know. 2 we do not know, so we can find that out as well. Let's quickly do the match wins here as well. Match underscore wins underscore df. For match wins, we use the winner column, and then we find out value counts for this as well. Here as well, let's mark it as sort equals true. So we've got the match winners, all the counts for the match wins and toss wins for each of the teams. Now, if you want to like showcase them, so you can do that as well for ID and val. And since we have encoded them, so it might be a little difficult. So we'll have to like back reference the dictionary. So we want all the keys now from the encoded values. So you can do it like this. So we'll run a loop over these. So let's say toss underscore wins iter items. So this is basically a series that we have. So now we'll run loop over this toss wins variable, and for each of these rows we'll actually try to look into, we'll find out what this one encoded value is for what team. So let's quickly print the results for that. I'm using an f string over here. So here it's very simple. So let's quickly, I'm converting the list team underscore encode dict, and I am going to use the winner column and then extract all the keys. So because we are interested in looking at the keys, so I've created a list of all the team variables, team names, and accordingly, now what we're going to do is we are going to get the value or the name of that particular team by, so basically the list starts from 0. So that's why I have subtracted this one for that particular index. And in front of it, I simply want to mention toss winner. So that is my toss wins. And for that particular IDX, that is it. So I think this should run. So now if we run this, okay, we have an invalid syntax error. Let's quickly address this. Okay, print f string team encode dict winner keys. Then we have got the keys over here in the list. And IDX -1 is fine. Okay, I have to close it over here. Yeah, I didn't close this. So this curly braces needs to be closed. This was not closed. Now, if I run this, okay, yeah, this one is extra. Okay, this again. So this is all the toss wins. So you can actually again go from your encoding to your team names as well back. So this is how I have done it. I've first created a list of all the team names, and then I am referencing them by index. So for whatever iter item, so you can actually look at what this gives you. So it basically creates a zip of the ID and the value that it contains. So that's just about it. And then we iterate over it to get the value. From the value from the index, we go to the encoding to the actual team name. Similarly, we can do this for match underscore wins. So we saw that Mumbai Indians has won the most tosses. And if we look at match underscore wins, okay, we have got some error. Okay, so that is for 15 because of the draw column that we have at the end. So that's nothing to worry about. Matchwins.iter items. So this again, Mumbai Indians is on 98 and Chennai Super Kings 89. Match wins. Okay, yeah. So basically, there is some sort of relation between toss winning and match winning, and that we'll figure out. So you can one way to do that is to, again, we'll check them out in the modeling process, but let's first quickly plot the match wins. So match underscore df, use some visualization methods. Again, very simple, very easy. We can actually plot all the winners using the histogram. Bins equals 50. So, okay, this is currently running. And this gives me all the winners. So these are the team names at the bottom. Team numbers, sorry, team encoding. So first one is actually 109, which is Mumbai Indians. Second one again, second one was, okay, we'll have to check that out. So team encodings we can actually look at over here. Yeah, second one is Kolkata Knight Riders, and so on and so forth. We can actually predict, visualize these from here. Now, the next thing that we want to do is let's try to plot these together. So let's see what do we get there. Might give us some error because of the other thing. So match winners. This is match wins. So we are basically plotting. Again, I've initiated a plot with the figure size 8,4 using the Matplotlib library. Then I've created a figure which is I've created a subplot, which means that I want two subplots to be just side by side, and I've labeled the x-axis, the y-axis, the title of the plot, and I want a bar chart. So plot toss wins dot plot kind equals bar gives you that, and then we have at the end we did the same thing for the match wins. So let's quickly run that here. So you can see we have the match winners over here and the toss winners over here, kind of close. Match wins. Okay, so you can actually look at them side by side, and I think they are all the same. So let's quickly go back to check. Okay, we have toss winners, we did that correctly. Then match wins, toss wins is fine. Okay, match wins. Okay, yeah, if we do this, yeah, key error is for that. Okay, yeah, but basically this is how you can actually plot them together. There's some error with the match match wins over here. This is something related to the dictionary or the back referencing that we're using, and the draw that we have added at the end. But yeah, but basically this is you get the gist that toss wins or match wins, you can actually plot them together using subplot method, and add them labels and simply use. So these are like, both of these are data frames. So you have this plot method which actually leverages the Matplotlib library. Add them together and you can actually figure out like, okay, what is the relationship between the two, the toss winners or the match winners. Like, is there a direct relationship or what is it? Another way to do that is, again, correlation. You can check for the correlation as well. So match underscore df. Now let's quickly check for if we have any null values. So these are the columns. So again, based on what we are going to model. So let's quickly drop the redundant columns. So the next step is basically dropping the redundant columns. Again, we're doing so much of analysis, so much of data cleaning and other things. It's important because modeling is the easiest part in the machine learning process. Like, most of the time is spent on analysis and getting the data set into a format which we can actually use to model and get something valuable. So that's how it is. Let's drop the redundant columns. So dropping the redundant columns, we want to simply use a bunch of columns that we have set. So based on that, let's quickly set the columns of our data frame. Apart from these that we set, we don't want anything else. So you can actually add a list of columns for the data frame. So here in this particular list, I would mention all the columns that I want in my data set. So let's say I want team 1, which is which team is playing, the first team, then team 2. And now based on our analysis, let's say where we are playing is a factor. Then what toss decision was made. Then we have another feature, which is toss winner, who won the toss. And at the end, we also have a venue, where was this match played, another very important feature. And the last one is the target variable, which is our winner. So who won the match when it was played in a particular setting, in a particular city, in a particular venue, who won the toss. So all of those things. So now match underscore df. We have 756 rows and 7 columns. So these are the columns that we are interested in looking at. So we'll simply focus on these for now. And based on this, we are going to create and prepare our model for prepare the data set for the model that we are going to use in the machine learning segment. So here you can see we have the city column, toss decision, and venue column, which are still in object data type, which is basically this is all textual data strings that we have got over here. So we'll have to address this as well. Now, one way to do that is we can actually label and code them. So what we did with our team names, we can actually do that over here for these as well. City, toss decision. And the other method is the one hot encoding method, where we can actually create a variable out of each unique value of each of these columns. So here, let me quickly explain you like what label encoding is and what we are going to use. So let's say if you have this particular data where you have country, India, US, Japan, and age and salary. And you see that these two are numbers, but this is textual data, and you have to address this and convert it into some shape and form where it is actually understandable by the model. So here from country, what we are doing is we are encoding each of these countries, and we have assigned India as 0, US as 2, Japan as 1. So we have encoded these values, and this is called label encoding. And you can definitely see, like, every number that we have actually put there, it contains some value. So 2 actually means something. 2 is basically more than 0 or more than 1. So 2 has got higher weight. And that's why label encoding is not good for purposes where we are actually having non-ordinal data. So next up, so another method of encoding is one-hot encoding. So again, these are for all the categorical variables. So these are called, this is whenever we have a textual data, we have categories of values. Basically, we call them categorical variables. So country, we have India, US, Japan, same data. And now we want to create a variable out of each of these. So let's say we call India as 0. So we create a separate column, and we only mark 1, set the value as 1 for when that, for which particular, for that particular instance where it exists. So for I think for Japan we have set 1, which for, so that's why we see in the third instance we have Japan, and in the fifth instance we have Japan again. And US is 2, so again that is marked as 1 and 1 in the second and fourth instances. So this is how you can one-hot encode the categorical variables. And then one thing that you should notice over here is, so we had like 3 categories, and it created 3 new variables. So if you have, like, let's say hundreds of categories, so it'll add those 100 columns to 100 features to your data set. That basically creates increases the volume of your data set. So you'll have to figure out, like, there's a trade-off that you'll have to address. So based on these, you decide like which encoding method you should go for. And in our particular case, I'm currently demonstrating how you can do this with label encoder. But another home task for you would be to use one-hot encoding, again using the similar method. And you can check out the Scikit-learn documentation for how you can use that. Again, very simple. All of the major methods are actually very simple to apply. So let's quickly address this, how we can label encode our textual columns, these city, toss, decision, and venue. So first, from Scikit-learn, and we have a pre-processing module where the label encoder resides. We don't have to write that encoder ourselves. We have a label encoder class. So import the label encoder, and then let's say which all columns, we create a list of all the columns. So feature list, let's call it, and we set all the, we actually create a list of all the columns, textual columns that we want to transform. City, toss, decision, and then we have venue at the end. These are the 3 columns that we need to encode. Next thing is to, this is a class that we have. So we'll first have to instantiate this class. So let's create our encoder instance. So label encoder. So we have instantiated our label encoder over here. Now we can use this encoder to transform each of these columns. So how do we do that? We run a loop on each of these columns. So for feature, in feature underscore list. So we're going to go over each of these features. So how do we transform them? So match underscore df. Let's store the result, keep storing the result in the respective column. So this is how I can assign the new values. So here we are going to transform the feature encoder, and the method is fit underscore transform, and you pass the data to it. So the data is basically match underscore df feature. So for this particular column, all the columnar data for this particular column would be transformed using the encoder. So match underscore df, the feature. So this would simply update our column. And since we are running a loop, we will get all the values as well. We'll do that for all the three columns. So print encoder. We can actually look at the classes that it generates, it encodes. So I'm at the same time, I'm also printing all the classes. So this will basically print the list of all the classes that the basically in the city we would have like all the unique values. It will show you what all it has encoded. So match underscore df, let's look at that once the transformation has taken place. So here is this print statement in execution. So for the first, we have city, and these are all the classes for our city column, all the categories, Abu Dhabi, Ahmedabad, all the unique values that appeared in the city column. Then toss decision was fairly easy. We had simply bat, or you can field. And then another last column was venue. So venue again, these are all the classes that we have for the venue for each of these matches that have been played. So now we have team 1, team 2, city, toss the decision, toss winner, venue, and winner, all in integer format. So all if this is integer data type, and the machine learning algorithm that we will choose should not throw us any error, because it's all understandable by it. Now, as I said, I'm using the label encoder again. You should try it out with one hot encoding and see what the result, how the results would vary. So now we are going to run it. So first thing that you do, so the next step is basically the machine learning process that we'll start from here, since the data preparation is all done. Let's create a Markdown cell, run it. So here, what we're going to do is import the model that we are going to use. So first thing that you do is you have 750 rows, 756 rows, and 7 columns. So whenever you think about applying machine learning to predict something, you do that by first splitting the data. So you set aside some testing data at the beginning, which you will only touch when you have when you are convinced that this is the model that I'm going to go with. Once you have finalized your model, then you go and test your model, the final model with which you are ready to go into production. So here we are simply going to use sklearn.model selection and import train underscore test underscore split. This is the common method that we use, train test split. And again, for the same way, we have train underscore data frame and test underscore data frame. So these we'll create. This will basically split. We are basically trying to split the data set. So we'll reserve like 20% of it, which is like the general rule, 80-20. And you can again decide based on the amount of information that you have. You can like keep aside more test data, but that's on you. The general rule or the commonly used rule is 80-20. So you call train test split, pass match underscore data frame. This is the original data frame that we have, which we need to split. Then we set aside test data. So test size we need to specify. So test size, we say 20%, so which is 0.2. So we say reserve 20% for our testing set, and then we also set random state equals any value that you might like. So let's say 5 over here. So random state, we set random state so that every time we run this cell, it should create the same split, so that we can actually compare the values once we run the code. So it basically, so random, once we have set the random state as 5, it will always create the same split for the same value. So let's quickly look at the rows now. So print train_df dot shape. So shape attribute gives you the number of rows and column in your data frame. And similarly, let's print the shape of our test data as well. So training set contains 604 rows, 7 columns, and testing set contains 152 rows and 7 columns. And now we can actually go about implementing our machine learning model. So since this is going to be, so we have team 1, team 2, city, toss decision, and the winner is basically one of the teams that have played. So here our problem statement is around predicting the winner out of the 2 teams who have played in a particular set of conditions. Okay. So so since this becomes a binary classification, like out of the 2 only 1 can win. So from Scikit-learn dot linear model, I am importing the logistic regression algorithm, which is again the commonly used algorithm. I won't go into the details of these algorithms or how they're learning, what's the cost method, what's the optimization criterion, how does it learn. For that, we have like specific dedicated courses as well. Again, but this is going into the mathematics of the algorithm is beyond the scope of this particular session. So I am using logistic regression. You can check out with other classification algorithm as well. We are going to use one more, which is random forest classifier. Again, another ensemble method, which contains which consists of many decision trees, and then gives you the output based on the average of all the predictions made by those individual. So it is under the ensemble module, and we can import random forest classifier. And another thing that we'll need is, let's say we need an accuracy score for the model results. So that would be our metric. So it resides in the metrics module. So let's import that as well. Accuracy score. So from Scikit-learn.metrics, we have imported accuracy score as well. So that metrics part is done. Now the next thing that we need is we need to evaluate the model. So now the testing set, we said that we'll only touch it once we are convinced with once we're satisfied with the performance of our model. So how will we test it? So there's a better technique called cross validation, which we are going to use here to test our. So one way is to split set aside some part of the training set for validation purposes. That you can do, and that works fairly well as well. But another thing that we have, which is already implemented for us, and it's easy to implement, like if you want to do it yourself, is the cross validation that we are going to use. So Scikit-learn.model selection, import cross val score. And I'll tell you like how this works, cross validation. And yeah, so I think that's pretty much it. Let's get down to writing. So we'll try to write a function so that we don't have to like do it again and again for every model that we try out. So it's always important, always beneficial to write a generic function. So I'm writing this print model scores, and to this function what I'll do is I'll pass the model to it, I'll pass the data, I'll pass all my predictor variables, that is the independent variable of the feature variables, and my target variable. So I'll pass this. So this is again list of features. This is again the list of my target variable that I have. Okay. So now I have passed the model. So first I'll train the model on the data that I have got. So this data is basically my data frame, and I want to run it over the predictor variables. So this is basically my X data variables. So most of the times you would see data predictor is this is basically you see X underscore train and Y underscore train. So it's the same over here. So this is how we're going to do it. Model.fit, this is my feature variables, and I pass the training the variable which is the target variable. So again, since this is again I hope you guys all know that this is going to be we already know the outcome, we already have the data as labeled, so we already have a supervised learning, so that's why we're doing all of this. And model.fit, we have passed the features and the target. Now it doesn't matter we use this function for training purposes or testing purposes. You can do it for any any purpose. So model.fit, the model is now trained. The next step is to find out the predictions. So model dot predict, and here we are going to do that predictions over the data that we have. Okay, predictors. Okay, yeah. So we've done the predictions. We can actually print the accuracy over the training data itself, but that doesn't really make sense because we have trained it over the same data set. But we'll see how we can address that using cross validation. And we can check. So we can print the accuracy of this model using the accuracy that we have calculated. So let's quickly calculate the accuracy of that, of our predictions. So accuracy, we have the accuracy score function. And to this, we'll simply pass the predictions and our target variable. So we'll try to compare. These are the actual values. These are what the model predicted. We'll try to compare them, and this will give us the accuracy score for how many predictions were actually correctly done. Then we predict 0. We need 2 decimal values. So that's it. Dot format, and we can actually pass that. So I'm printing the accuracy over here and with the value. Then now we will also print the cross validation scores as well. Now in cross validation, what we do is in Scikit-learn, it creates a number of folds. So let's write the code first, and then I'll explain you how this works. Cross underscore val underscore score, and we do that for the model and the data predictors and the target variable. So here, this particular method also contains a scoring argument. So scoring argument is equals negative mean underscore squared error. And so basically this, how will the model learn? So there's an evaluation method, a loss function that we pass. So this mean squared error is that function that it uses to evaluate the model performance. Okay. And again, it takes CV, which is basically where it takes like number of folds that it has to create. So here you can actually pass the number of folds that you want to create. Now, what does this fold mean? So cross validation, what it does is it basically creates, let's say we have created 5 folds over here. We have passed CV equals 5. So cross validation will create 5 folds. Now the model will train on 4 parts and reserve the last part for testing. And this process will run 5 times. So the CV equals 5 basically suggests that it will run 5 times on each of these folds, and use each of these folds for testing purposes one time, and train on the rest of the 4. So that ways we actually use the entire training set in all the possible ways. And again, it's a very easy and automatic way of actually checking how the model is performed, how the validation scores are coming in. So this part of cross validation is done. So this will give us 5 scores for each of the runs. So here, so the scores basically would be a list of scores. So let's try to print all of those scores. Cross validation scores, and we can dot format and we can pass. So we need to call the square root. So these are mean squared errors, and these values basically give you a negative. So this is, since this is an error, so they give you a negative value. So when you want to calculate the square root of these, you would have to add a negative sign by yourself so that you convert it into first positive values and then you calculate the square root. Otherwise it will give you an error. So that's that. And then we predict the average root mean square error value. So this is the root mean square error that we are printing over here. And then we calculate, let's say, the average value, average RMSE is NP dot square root. So NumPy, basically I'm using NumPy square root method, and I'm passing the list of scores. It will run the square root on all the methods, and then we are interested in looking at the average, so mean, and that is it. So our function is now ready. Let's run this. So we'll use this function for all the model testing, and let's quickly check it for logistic regression now. Let's say, okay, logistic regression. So here, let's check. Let's first decide our target variable is going to be winner. Winner is our target variable, and then we need to pass the predictor variable. Again, you could have done that like at the beginning as well during the data preparation. If you want to like segregate the two, like the winner column set aside in the beginning and all the feature variables again, you can do that ways as well. I am mentioning all the names, predictor variables over here, team2, venue, and similarly, let's just, okay. Okay, so we have team 1, team 2, venue, toss winner, city, and toss decision. So these are the 6 columns, our feature columns, and this is my target variable. We have instantiated the model, logistic regression model that we are using for this prediction. And then we simply write or call the method that we have written above, print model scores. To this, first we pass on the model that we have defined over here. Then we pass the data, which is which is train underscore df, the training data set. And then we pass the predictor variables, and we have the target variable at the end. So this is ready. Now, if we run this, let's see how this gives us. Okay, name predictors is not defined. Okay, we have added predictor somewhere. Okay, the accuracy is 0.32, that is 32%. And the cross validation scores, you see, we have 5 values for each of the folds. So it's giving us the root mean square error for each of the fold. And average root mean square error is 3.55. Now, this has really made our task of testing the model or evaluating the performance of the model really easy. So we can test now any other model. So random forest, and we'll we'll try to check how the predictions are being run and all of those things in just a bit. So random forest, let's check that algorithm as well. Okay, again doing the same thing, model equals random forest classifier, define the model, and we can set, let's say, number of estimators. So number of estimators is the number of trees that we want in a random forest classifier. So random forest classifier is an algorithm which comprises of many individual decision trees, and based on those individual results, it averages the result and gives you a better generally better outcome, a better prediction. So number of estimators equals 100. We want 100 trees. You can change it as per your choice. So now next thing that we do is simply print model score function, and here we pass the model, the train df, the predictor variables, basically these. Run this. Let's see how does random forest classifier does. So it is, again, accuracy is pretty good, 89%. Okay, and the average root mean square error is a little high, but accuracy is good. Okay, fine. So let's try to run a sample prediction. So let's say we want a match. Let's create a sample instance first. So we have team 1, let's say Mumbai Indians. I have this sample instance created. So let me just quickly use that itself. See, we have Mumbai Indians, Sunriser Hyderabad, which is team 2. Then we say toss winner was Sunriser Hyderabad. And then input is basically, I've created this list. So team 1 is Mumbai Indians. So we'll have to encode it first. So we have encoded the data using the team encode dict as earlier. And then we have encoded the team 2, 14. This is for the city, the code for the city, and team encode dict. This is my toss winner. And then similarly, this is venue, and this is for our this is the last venue. Okay, last thing, last variable, which was toss decision. Okay, so this is, again, this is like a list. So we'd first have to convert it into a column. So we need a 2D array. It accepts a 2D array. So what this reshape method here does, what it does is, so it will create 2D array out of this 1D list that we have over here. So this input is currently 1D list, but we need a 2D array for our model prediction. So print input. So we'll check what this input actually gives you and how does it. So what it was, let's print it before as well, before the reshape, so that we know what the reshape method actually does. I'll create a numpy array, and then after creating an array, it'll reshape it to a 2D array by converting it into a column based array. Then we pass it to the model.predict, and the winner is basically, again, we are using the same back referencing method to find out. This model.predict will actually give us the encoded value. So let's predict output as well. Let's run this quickly. So this was our input. After the first input, the second input was a 2D array, as you can see. This is a numpy array, and then the output was simply this value 1, and 1 is encoded for Mumbai Indians. So if a match is being played between Mumbai Indians and Sunrisers Hyderabad in a particular venue, which is encoded as 14, I don't know what the value here it is, or in a particular city, in a particular venue, with a particular toss winner and decision, then Mumbai Indians is the team that's going to win the match. So that's how you can use these models to predict. Again, you can check for another thing that you can do is you can check which all. So we have a number of features over here. So you can check which all variables were important based on their scores. So you can check the feature importance. So we get that as well for data equals, so model dot feature importances, that gives you that. And we look at, okay, so we have team 1. So this is, I printed the predictor variable as well as their respective feature importance score from the model that we have run. So this model is currently random forest because that's the one we have defined over here at the end. So team 1 score is, team 1 is 0.22, team 2 is 0.24. So these are the two most important variables, again, because they are being used, and these are the actual teams that are going to come out as winners. And then after that, we saw that venue plays an important role in predicting who the winner is going to be. After that, we have toss winner, city, and toss decision doesn't really have that much effect on who's going to win. So that's what the model is suggesting. Now we can look at other ways to predict the data set. So I'll just quickly show you, we're running out of time. So I'll show you what the, okay. How do I hide this? So again, this is like one way or one method of looking at this data set from one particular angle. As I said, there are so many variables that you can use or that you can predict. So I have done that analysis for adding some more complexity to this code. So right now we are simply using the match data frame, match data, but you can actually combine it with the deliveries data and do a much more sophisticated analysis, which would comprise of scores as well. So here is what we have. Okay, so you can check and you can plot if, let's say, Mumbai Indians and Chennai Super Kings are playing, you can plot. So this is a plot for winner and toss winners, and as well as match winners. So this is the team for that. So if we are playing against them, so how many times are they winning? So this is the plot for that. And if, let's say, for your home task, I have done this analysis, I've added a bit more complexity to the next task, which is merging the data frame of the delivery by delivery data set. So here what I've done is I'm quickly just going to walk you through like what the steps are. So first of, I have match ID and batting team. I have just grouped by match ID and batting team so that I can get the score of each team. So delivery underscore data frame does not contain what it's delivery by delivery data set, so it does not have what the team scored during the match. So we can actually run so there's this batsman underscore runs column where we can actually invoke this sum method, and it'll give you the entire score of that particular team, of the batting team that was playing. So if you see the data after grouping by match ID and batting team, we have for each match ID we have like two teams, so there'll be two rows for each ID. So batting team Royal Challengers Bangalore for the first match and Sunrisers Hyderabad was second. Now we need it in a format that we can merge it with the data that we have already. So we need to merge it with this particular data, and we actually want these two variables to go like team 1 score and team 2 score by capturing these values. So how do we do that? We try to first again create this match underscore data, the data frame that we have already picked. So here what we're going to do is we are simply going to group them by team 1, team 2, and then find out like who the winner is going to be. So based on these two, we are actually trying to predict, like find out who the team 1 score is, what the team 1 score was and what the team 2 score was, and adding the scores to the merged data frame so that we can leverage that as well in order to predict the score or whatever that you want to do. Similarly, you can also use these columns for other purposes as well. Then again, I have added a dictionary where I am adding these columns one by one. So this is like another method of creating a data frame. So in this new data frame, I want match ID, I want team 1, which I will get from this team 1 list of teams data that I've created. So this is my data of teams, team 1, team 2, and who the winner was, that I've got from our original match underscore data. So I have team 1, team 2, and similarly we have team 1 score and team 2 score, and winner we have a list of team winners that we have defined. Now team 1 score and team 2 score are going to come from the deliveries dataset. For that, we have written this for loop, and here we are simply going to query match ID from the team and the batting team that was playing, and we calculate the batsman underscore runs for that, and we append it to the team 1 score. All of this just to get this particular data where we have team 1, team 2, team 1 score, and team 2 score and winner. So this is where this is what we have created from match underscore data frame and the deliveries data frame. Now we are going to merge it with the original data frame after encoding the data. So this encoding part is done. So now we have match ID, team 1, team 2, team 1 score, team 2 score, winner. And then I have merged it by first segregating. So there are some common columns, team 1, team 2. So I am simply just dropping them off here by calculating the difference in columns. And then I'm merging the df with the match underscore df that we have been using. So this is what we get after merging the data set. So this is my merge data frame, and I can use this data to do more analysis or predict the score, which is team 1 score or team 2 score, and again use these to find out new winners or another adding new feature to the feature variable list to find out who the winner is going to be. So this again adds scores. Another way, if you want to add more complexity, you can add the batsman score, who all batsmen played, and one hot encode them as well. So that is again to add more value. So how will you predict the score? So you can convert this. This is going to be a regression problem, but you can convert it into a classification problem. How? You can actually set the criteria, basically, that if the score is between 0 to 50, you have encoded it as 1. If the score is between 50 and 100, it's 2. If it's between 100 and 150, it's class 3, class 4, and so on and so forth. So you can categorize those columns. So here I've categorized the scores as columns, and then if you're predicting, like, if these two teams are playing, what will be the score of team 1 score if it's being played in a certain set of conditions, then you can actually predict, like, what would be the score for that particular team. And similarly, you can check for the correlation of the variables that we have created over here. So we have a heat map where this correlation method. So on a data frame, you can run the correlation method, and it'll give you how one variable is correlated with another variable. So if, let's say, is it like, if one variable increases, so does the other, or does it go down? Is it like opposite of what happens? Or is it just stays in place, or there's no effect? So negative correlation is the range of correlation is from -1 to 1, and this is +1 because these are like for the same variable. So match underscore df, we have variables over here, and on the x-axis as well. 1 is like perfect correlation, 0 is like poor correlation, and negative correlation is my negative score. Negative is again like perfectly negative correlation is again fine. If, let's say, one quantity goes up in one direction, and then the other quantity will go in equivalent steps in the opposite direction. So again, this was the correlation. Now the home task for you guys would be to predict the winner using one hot encoding, first of all, for the match data frame, and then analyze data for batting and bowling performances. That is, you can check out the notebook, the GitHub repository. I'll share the link with you. So this deliveries underscore data frame, it contains like who all are the top bowlers, who are the top batsmen. So you can check out, you should perform a detailed analysis on all of those performances, on all of the delivery by delivery data. So then the third task would be to try to predict the category of score for a team that we have covered over here in this particular data set. So that's about it. Now I'm going to take a few questions. If you have, please add it in the chat, and I'll go over them one by one. The link has been put in the chat, so yeah, you can check that out from there. And if you want any of the basic details, like how does logistic regression or how does random forest, all of that works, we have like specific courses that you can opt for, or we might consider to cover them in some other webinar. So yeah. Please keep putting your questions in the chat, and I'll try and answer a few of them. Which Python libraries would you suggest? So first of all, as you saw, Pandas, Numpy, and visualization are the most important tasks when you are, uh, going about preparing the data set, or even if you're interested in practicing machine learning, this is something that you should all know definitely, and you should be like you should have a good grip over these fundamental libraries. So I would say Pandas is something that you should master. Pandas, Numpy, you should know how to use them. Then basic programming, again, that should be perfect in the first place. Like not perfect, but you should be like, you should know how to write object-oriented code, how to write functions, and all of those things. Then Pandas, Numpy, Scikit-learn, visualization library, Matplotlib, Seaborn is something that you can pick up once you are like comfortable with Matplotlib and basic plotting libraries. So these are the ones that basically comprise most, that basically help you accomplish 90% of your analysis tasks. So everything revolves around Pandas, Numpy, and Matplotlib. And then if you go into machine learning, then you can use Scikit-learn, which is very comprehensive, covers a lot of algorithms and everything. Okay, can you put some light on, Vaibhav has asked, can you put some light on where to use which visualization? So, well, that's very contextual and very subjective. Again, Vaibhav, but yeah, as I said, if there's something that that you're interested in, let's say count, then you decide, okay, bar plot is something that I can use. Then if let's say another case is for outlier analysis. So when your data set contains a lot of outliers, you use box plots to do interquartile analysis and find out like where the outliers are, or how many of them are there. And then you use, so that's basically a basic interpretation, or basic plotting fundamentals. So like a pie chart should be used when you are just, when you have like 2-3 categories and you want to segregate like how much of what is contained for a particular category, like what's the value, how the demographic or something is distributed. And then what all do we use significantly? Bar chart, histograms, and then line plots is something that shows you, let's say you're picking up financial trading data, there the stock market prices keep going up. You have daily and end of day stock prices, so you find out like how the price is actually moving on day-to-day basis. Is it going down, up? So that's important over there. If you want to track like everything, so time series analysis gives you, the line plot gives you a much better view there, and so on and so forth. So keep working on different problems and you'll figure out, okay, like what sort of visualization help me interpret or derive more insights out of my data. Okay, we have, let's me take a last question. Okay, we have a question from Snehalata Single, who has asked how to determine whether regression, classification, or any other type of problem, which will be the best in a particular case. Okay, so again, that also depends again. on what you want to predict, how you have formulated your problem, and based on, so you'll most of the time you have an idea like what you want, what the objective is. So once you're clear with your objective, you'll figure out like, okay, is this going to be a regression problem where I'm going to predict a continuous value going forward, let's say in a house price prediction case, or where the stock price is going, and what would, if I want to predict the stock price, how, so that's also going to be a regression problem. Then if let's say something like classification, where you have spam, not spam, fraud detection is something that is being used very widely across industry in the fintech sector. So there you have most of the classification problem, and yeah, so it basically it's very contextual. It depends on your business problem. So if you are clear with your objective, you will find out what sort of problem it is, like supervised or unsupervised, what sort of data set that you have first of all, and then you decide like, is it going to be regression classification, or is it going to be anomaly detection, or customer segmentation, or any of the other unsupervised problems. Okay, please recommend some basic problems to start for beginners. Okay. Start with a simpler data set like house prediction. If you want to start with machine learning, if you want to start with the data analysis, you can keep on looking at like basic data sets from different repositories, like Kaggle data set. Pick up a very simple data set and try to explore the data and try to find out like how each variable, how each feature is contributing, and what all values or what all insights can you derive. So once you have like a good understanding of how it would work, or how each variable is contributing to the data, what the value of that variable is, then from there, from analysis, you can like move on to go about predicting a particular feature, or predicting anything that's basically the objective there is. So you can pick up a very basic data set and start doing things, and that'll be all. And then meanwhile, if you get stuck somewhere, go on the internet, read a few articles. That's how you learn. Okay, I think that brings us to the end. Okay, let me, one more question. Any tips handling seasonal data for prediction? Yeah, so you might want to go into, learn about time series data, and that covers a lot of it. I'll, like, off the top of my mind, I haven't done like too much of time series analysis, just the fintech sector. I have done a little bit of that, but yeah, you can like connect with me after this, and I'll be able to help you out with your specific query. There are a bunch of repository links. So you can actually look at one of my blog posts as well. So where I have covered like all the data repositories that you can use. Nagarajan has asked best repository data set other than Kaggle. You can check that out. There I have provided and reviewed all the repositories that are like that are really good data repositories for different sectors, like scientific, astronomical data, or similarly just a vast repository like UCL or something of that sort. Okay, I think that brings us to the end of this session. Thank you so much, everyone, for attending, and thank you so much the TAs that have been working and answering all the questions. Yep. Thank you so much for attending this, and I hope to see you again in some other webinar. Catch you guys later. Bye.